I wasn't recording. So when we talk of rates of change, we are talking about the rate of change of any quantity is the differentiating of that quantity with respect to time. So rate of change of volume will be dividing all over the t. You are differentiating volume with respect to time. That of velocity, rate of change of velocity. That means you are going to differentiate with respect to time. That is it. Now, under this class, we are going to talk about increasing and decreasing. And so when the question states that maybe the rate of an area is increasing at a rate of maybe 0.7, then that means you are going to add. When it is increasing, that means you are going to, it's going to be positive. That means there's a positivity. Every increase is positive. Now, so for instance, when they say the rate of increasing of one radius is 0.7, then that means you are going to maintain the 0.7 because it is positive. Now, when the question, however, when the question says it is decreasing, then that means when we are given 0.5, we would have to negate it because it is decreasing. I hope I've made myself clear. So when it is increasing, we maintain the value you are given, which is a positive value. Now, when the question states that it is decreasing, then that means we would have to negate it just to show that it is decreasing. I hope I've made myself clear. Now, suppose the radius of the radius r of a circle is 4 cm. So let's suppose that the radius of a circle is 4 cm. So radius of a circle is 4 cm. Radius is denoted by small r, 4 cm. At a certain instant, and it is increasing at a rate of, so it is increasing at a rate of, so increasing at a rate of 0.7 cm per second. At this instant, we wish to determine the rate at which its area is increasing. So if it was to be in a question form, the question would say that determine the rate at which the area is increasing. So determine the rate at which the area is what? Increasing. Now, so the question is, we are to determine the rate at which the area is increasing. So we are talking about the rate of the area increasing. And so that means our question will be now, this will be now the area all over the t. Sorry, all over the t. So this is what we are finding, the area all over the t. Given the values above, which is having our radius being r and having a rate of then by 0.7 by second. So this is what we have. Now we've been given that of r, and we've been given that of but we are asked to find for the rate of increment of what do you call it, area. So what we are going to do is, you know that the a, so the a, we are going to use the a all over the t is given by the a. You know, we can express the a with respect to r times, times the r, the r all over the t. Now, this is the same thing. I hope you know it's the same thing. I hope you know that the whole of this is the same as this. We just express it differently. I hope you know that. Because when you have to look at this thing, when you write it in your books, this and this will cancel, and you still get a d all over the t. I hope you know that.
Yes.
Now, we also know that area of a circle. Area of a circle is given by what? Pi. It's given a pi what? R squared, right?
R squared.
R squared. So that means we are also going to use all these things here. So what we are first going to do is, so we have pi r squared here. So that means we can find for our dA all over dr, because we have r here. So that means we can differentiate this a with respect to the r here. Are we there? Are we there, please? Are we there?
Yes,
oh, please, I want the rest to talk so that I know that they are getting what I'm teaching.
Yes. Yes, sir.
Okay. Maureen, how are you? Maureen is here. I thought she's not. So So when we are differentiating the A with respect to the R, the A, the R, what are you going to get? I want to get 2 pi r, right? That's what we are going to get. 2 pi r.
Yes.
Now, so now we have our d all over the r. That's what we have. But you know that the r, we are giving r to be what? 4 cm. So we can start anywhere we see r, we can substitute our 4 cm into it. So then we can get the a, the r is equal to, help me, what are you going to get? 8, right? 8 pi.
Yes.
I'm going to get 8 pi. So we have now we have our the a, the r. Now you are supposed to find for the r all over the t. But the question is saying that it is increasing at a rate of 0.7. At a rate of 0.7. Now the 0.7 cm, the cm means that it is distance, and distance is radius in this sense, and the seconds means is time. So we can say that the r all over the t is equal to 0.7. Have I made myself clear?
Yes. Yes.
So the r all over the t, so our the r dt, we can say that our the r dt is 0.7 cm. So this we are giving the value straight away. So our the r dt is equal to 0.7 cm per second. So the cm is the radius distance, and the t is the seconds. So the rate of this, so the r dt. So now we can factor the whole of this into the a all over the t. And I told that assuming the question said it was decreasing, then that means we would have to negate the 0.7. But because it is increasing, we would keep it positive. So what we are going to do is, so now the a dt is equal to the a dt is equal to the ADR, we had 8 pi, right? 8 pi.
Yes.
Times 0.7 or times 0.7. 0.7. What are you getting? Please use your calculators. What are you getting?
5.6.
5.6. So our dA dt, we are having 5.6. 5.6 pi. There's supposed to be pi. Now convert the pi to this thing. So we are going to get, so dA dt is equal to, this will be 5.6. We can decide to leave it in pi, or we can also decide to say 5.6 times pi is what? 3.14.
Yes.
So the a dt, what are you getting?
17.6.
17.6. Please, what will be this thing? What will be our unit? There's supposed to be a unit. What will be our unit?
So cm squared all over is
Cm squared per second. So this will be our answer. So rate of change. So when we talk about rate of change, we are talking about a certain quantity differentiating a certain quantity with respect to time. So we said it, and I said that anytime we are giving an increasing this thing, then that means we are going to leave the value you are giving in positive. When it is decreasing, we are going to negate it. I've already said that. So this is what we are going to do. So that's how we are going to solve anytime we are giving rates of change. There's 1 or 2 ways of solving rates of change. There are some instances you even be given, and what do you call it? Now let's take one. The radius r of a circle. The radius r of a circle. The radius r of a circle. Radius r of a circle is 8. It's 8 cm. It's 8 cm. I hope you are writing. It's 8 cm. At a certain instant, and it is decreasing at a rate of 0.4. So decreasing rate is 0.4 cm. Bella, at what rate will the area A be decreasing at that instant? So at what rate will the area A be decreasing at that instant? You have to do it. It's similar to this one. At what rate will the area A be decreasing at that instant? So do it, and let's see.
Senior high school, sir, or more ambre, I'm one and you're Mokakra. And when I discuss in the branches, and yet I'm punching the engineer. And the Ghana Education Service of the Ministry of Education for a young teen engineer. How come the Abaya, yeah, what were we? No more prima, yeah, and no, and I'm on my young Nah. Such a Kumawu district chief executive, which is our home, Yawano someone at the Educum. And the engine is a son said the NCB. Now, one was watching, and I was not, but I never decided to the answer. What did you need? I made a ship on school. We are okay. Oh, we are okay. We are sister partners with the car. We are okay. I can't. Says Yato, just a more agile. And so bad that said the ticket from Panama, a go through. And the Shia comes from what Adamasi Senior High School. One also as for the year good to come. Adaya, one more best school near man, down hall, a Ghana from somebody. They buy it, make sure they buy a more work than ye, and February. The eye. I didn't see
Bella, for that, I found him.
Yes,
I'm not still now. I'm not still. Okay.
I'm a genius, but yes. Yes, I never had my father. Yes, also dining home when your father was dining here, and you took a shirt. This is the say, I can't have one next match. I don't know what you want to buy your crop. Let's say, actually, I'm a chapter for grandma. Yeah, open cry and show cry. The Robert Mayono. Yeah, it's to go and I'm what is. Yeah, okay, Papa,
What did you get? What do you get? What do you get?
So that's negative 20.11 cm squared
Okay.
per second.
Okay. So now you can write, hence the rate at which the area is decreasing is, then you take away the negative. When you're writing hence, the negative only means that it is decreasing. Are you getting it? But your final answer, you let it reflect. But now when you come and say therefore, the rate of area of decreasing, immediately you add the decreasing, you don't add the negative. You got me?
Yes, sir.
Uh-huh.
Yes.
Let's try some more. I always want to give you other types of questions so that anyone you meet, you can be able to. The volume of a sphere is growing at a rate of 24 cm cube per second. The volume of a sphere is growing at a rate of 24 cm cube per second. When the radius is 6 cm,
Please at a rate of
24 cm cube per second. 24 cm cube per second. When the radius is 6 cm, find the rate of increase of the radius at that time. When the radius is 6 cm, find the rate of increase of the radius at that time. Find the rate of increase of the radius at that time. Start work. Hello. Hello. Oh, mommy, I'm Maureen.
Hi. Yeah. Hi.
Maureen, what do you get? Are you done? What do you get?
So please, I had 1.5.
You had 1.5. Hey.
Say no. 3845.
384 pi. Okay, we'll solve it. So you get who else? Who else?
Say the reason why I had two answers me.
So tell me. But you know that you are going to use the what we call it, the equation of the distance, the formula for the distance, the sphere.
Yes.
So what is the formula for sphere?
The volume of a sphere.
Yeah, the volume of a sphere.
4/3 pi
Pi
r
r
cubed.
cube. So divide all over the r. What are we going to get? Because we are given r. So divide all over the r will give us. What are we going to get? It's going to give us 4. Is it what?
Sir, please, is it r squared or r cubed?
R cube.
Oh, yes, sir. So that's where I made a mistake.
Oh, don't forget its volume. It's not area, please. The volume of a sphere. You are not talking about the area of a sphere. Who else? Harriet, what do you get?
0.05.
0.05 what? cm cube. Is it that one? Oh, mommy. Harriet, 0.0. Ruben, what do you get?
So please, I'm lost.
You are lost. Okay, so let's all do it. So we are going to get the V, the R is equal to what? The V, don't do the V slash, someone should tell me the slash the what?
R.
The R times
the I.
times the R, the T, right?
All over
The T.
Yes, sir.
So we are first going to find for the V and the T. The V, the R, sorry. The R. The V, the R, what are you getting? Before we can find for the V, what is the volume of a sphere is what? 4/3 pi r cube. So first of all, the volume of a distance is equal to 4/3 pi r what? Pi r cube. So we are going to get this. So from there we are going to differentiate v in respect to r. So we are going to get, when we differentiate, 3 is going to multiply this. We are going to get the 3 will cancel this one. We are going to get 4 pi r squared. 4 pi r squared, right?
Yes, sir.
Pi r. So that's what we are going to get. So that's what we are going to get. So after getting this, but we know r, we are giving r to be 8. So just as we did this for the first one, the v, the r is equal to 8 times this will be 8 squared there. So 8 squared. Are we given? We are given. Yes.
Yeah, it was.
I said the
We
volume of
just
a sphere is growing at a rate of what? 24 cm.
So the radius was 6.
6. So the radius is 6. Sorry. 6. So the radius is 6. So let's factor 6 here. When we put 6 here, what are you going to get?
144 pi.
144 pi. 144 pi. I'm coming. So the rate at which the volume is increasing is given by d v all over the t. When the radius r is 6 cm, then d v all over the t will be d v all over the t will give us d v all over the t will give us 24. It says find the rate of increase of the radius at t, but the volume of sphere is growing at a rate. So the volume of the sphere is growing at a rate. So that means under normal circumstance, this is supposed to be the v the t. The v the t. Do you get it? Do you get it?
No.
Okay. So I understand why. Let me clean this so that we start again so that you get it. I just realized it. Yes. So yes.
Wait. Please, is it because of the unit?
No, not because of the units. Because the question states that the volume of the sphere is growing at a rate of 24 cm. So that means at a rate of 24 cm. So the volume of the sphere. So that means the v the t is 24. cm cube. Don't forget I said cube or per second. So the v all over the t, that's what we are given, 24. And so the rate at which the volume is increasing is given by d v all over the t. So we have our d v all over the t. Now after that, when the radius r is 6 cm, so we have the radius r is 6 cm, d v all over the t is 24. That already we know. Now we wish to find the rate of increase of the radius. The rate of increase of the radius. So when the radius is, find the rate of increase of the radius at that time. So the question says we should find the rate of what?
Increase.
Increase
So
of the.
we are finding.
So we are going to find for the RDT.
RDT.
We are looking for the RDT. Initially, you know, when we started, we were looking for the V all over the R or something. But I just read the question again. The question says you should find for the rate of increase of the radius at the time. So you are finding for the RDT. So the R, the T. That's what we are going to find. So by the chain rule, the R, the T, for my eyes, the R, the T will give us what? By the chain rule, the R, the T, what would the R, the T give us? It's going to give us the R, the V times the V, the T. Are you getting it? Are we getting it now? Hello?
Yes, sir.
Are you getting it now? Because the question states that find the rate of increase of the radius at that time. So we are finding for the RDT. So the RDT, because we've been given the V and all those things, the V all over the T is here, which is 24 cm. The R all over the V. So the R all over the V. So that's what we have. When this and this cancels, we are going to get the R all over the T. So this is the same as this. I hope you understand it to this point. So then now we are going to find for, so just as we did it, I think so we are going to find for this and we are going to find for this. Already we know this is 24. So we are left to find for the R all over the V. The R over the V. So what we are going to do is, but we know the volume is equal to, the volume of the sphere is equal to 4/3 pi r squared. When we differentiate with respect to R, so when we have the R slash the V slash the R, we are going to get, just as we are, 4 pi what? 4 pi r squared, right?
Yes.
R squared. But we are looking for divine. You are looking for the R divine instead. So what we are going to do, we can reciprocate it to get the answer. Because if divine, the R is given as this, then if you want the R divine, then you can reciprocate it. Are we getting it? That's mathematics. And so the R divine can be given as 1 all over 4 pi R squared. Are we there? Oh, talk to me so that I know you are following. Hello.
Yes, sir.
Are you there? Do you get it to this point?
Yes, sir.
Very good. So now the R dt is equal to, so we have the R divine is equal to 1 all over 4 pi R squared. But we know R is equal to 6 cm squared. So we can factor all these things into it. So we are going to get 1 all over our 4, we had 144, 144 pi, 144 pi, right? Times our 24, divinity is 24. So what are we getting? The R dt is giving us what? So this will be our final answer.
3,456 pi.
That will give us what? So 1 all over. So just what we can do is we can 24 go into 114? This simply means that check your calculations or
Say yes.
okay, 144 pi times 24. So now do the mathematics. This will give us 0 point something something because it's divided by this. So check.
0.053 pi. 0.053.
So 0.053. So in other words, I think this can go into this. 144 divided by 14. What are you getting? 144 times 6 will give us what? Check for me. Let me use it.
6 times.
6 times. So you can say this will go into this. It's 1 and go into this one 6 times. So we are going to get the R all over the T will give us 1 all over 6 pi. So this will be our answer. So the R, the T. Take note that this evening we will solve questions. The R, the T. Maureen, enter my DM, Enter my DM. So
Yes, sir.
we're going to get something like this. I hope you are getting it. So we are supposed to read the question first well and know what we are finding for. We aren't finding for the T. We aren't finding for divinity. We are rather finding for the RDT. So the first approach was wrong. I didn't read the last part. Talk to me.
Semi, I thought you can use the same formula and just make the RDT the subject.
The subject and you
Whichever way. But you just have to make sure you get to this because you are going to use the parameters to solve the question. And the parameters, you have volume of the sphere here. So you are going to talk about the volume of the sphere and all those things. So that means all of them have to come into play. Are you getting it?
Yes, sir.
Yes, sir.
So we solve more questions so that we get it. And our next class, or we should join again so that we solve 1 or 2 questions. What do you think? Or you are tired?
Say homework.
Okay. So the time is almost up. So I'll send you questions on the platform so that you solve it. So you have to read the question well.
Yes, sir.
I think so. You have to read the question very well. So have a wonderful day.